Welcome back to another Orange Coast College mathematics video. In this video, we are talking about some additional trigonometric identities. So this is similar to the last video. We just have additional identities to add to your bank of available trig identities. We call these double angle identities because we can find the sine of 2a, the tangent of 2a, and the cosine of 2a using, or rather in terms of sine, cosine, and tangent of just a itself. You, of course, could do things like the secant of 2a by just finding the cosine of 2a and doing the reciprocal. So with these three, we really do get them all. In fact, you could even do the tangent of 2a by doing sine over cosine. So there's a variety of ways to piece these together. But the kind of questions we're going to ask in this video are the same as the last video that we worked on. In this video, we're given, or rather in this example, we're given the tangent of x is equal to negative 1/3. We know that we're in quadrant 2 and we're being asked to find the cosine and the tangent of 2x. So let's start finding the cosine of 2x. We can use any of these identities to do it. Let's say, for example, I wanted to use 1 minus 2 sine squared of half of 2x would just be x in this case. And you certainly could, but to do that, I would need to know what the sine of x is. So really, I'm not quite ready to do that step. Before I do this work, I have to use the given information to find what sine and cosine are. So let's sketch a quick picture like we did in the last video. I know tangent is it's going to be in quadrant 2. So I've got an angle that looks somewhere over here. Tangent is opposite over adjacent. So this opposite is 1. The adjacent will be a negative 3 because we're moving to the left. By the Pythagorean theorem, we can do 1 squared plus 3 squared must be equal to the radius squared. So r squared is 10, or r is radical 10. That means that the sine of x is opposite 1 over radical 10. And the cosine of x is adjacent negative 3 over radical 10. So I have these values now if I need them. So going back to this particular problem, we see that we have the cosine of 2x is equal to this. So that's going to be 1 minus 2 times sine, which is 1 over radical 10 squared. Well, that's just 1 over radical 10 squared is just 1/10. So this is 1 minus a fifth. If you have a whole pizza and you take a fifth of the pizza away, you have 4/5 of the pizza left. Or of course, we could write it as a common denominator. Now, tangent of 2x we could do in one of two ways. One way is we could say, you know what, let's just use the sine, find the sine of 2a, and then divide sine over cosine. That's useful if you don't remember this identity. But we could use this identity directly. This is going to be 2 times the tangent of x over 1 minus the tangent squared of x, which is equal to 2 times, the problem told us that the tangent is negative 1/3, that was given to us, over 1 minus that negative 1/3 squared. Well, this is negative 2/3 over 1 minus 1/9. That's negative 2/3 minus 8/9, or divided by 8/9. So it's just the same thing as times 9 over 8. And I get 3 over 4, so I get negative 3/4 is my value for tangent of 2x. Now we would be done, but there was one additional question, which is asking what quadrant is this angle 2x even in? Well, notice that we were given that we started in quadrant 2, and then we found out what? We found that cosine of 2x is positive, and we found that the tangent of 2x is negative. So what quadrant can that be in? Well, cosine is positive in quadrant 1 and quadrant 4. That's when cosine is positive. But of those two quadrants, the only one where tangent is negative is quadrant 4. So quadrant 4 is the quadrant that this angle will be in. All right, let's go ahead and do another example. And this is going to be similar. So if you want, you could pause the video and try this yourself. So we're given that cosine of 2x is equal to 1/3. Now, this is a little bit different than the last problem in that here we're being given the cosine of 2x, and I'm asking something about cosine and sine. So let's use our double angle identity again. Let's use cosine of 2x being equal to, I, I could use really either of these. I guess I'll find cosine. So I'll say this is equal to 2 cosine squared of x minus 1. So 1/3 is equal to 2 cosine squared of x minus 1. If I solve this by adding 1 to both sides, I get 4/3 is equal to 2 cosine squared of x. Dividing by 2 is 2/3 equals the cosine squared of x. So cosine of x is equal to plus or minus the square root of 2 over 3. Now, given that we say x is in quadrant 4, since x is in quadrant 4, we know cosine is positive there. So really the cosine of x is going to be just the positive radical 2 over 3. I can rationalize by multiplying by radical 3 over radical 3 and get that the cosine of x is equal to radical 6 over 3. All right, now looking for sine. We can do this in one of a couple ways. One is we could go and repeat the process and use this identity again. That would be perfectly fine. Or I can sketch a quick picture. Now that I know the cosine is radical x over 3 in the fourth quadrant, I know that the hypotenuse is 3 and the adjacent is radical 6. Using the Pythagorean theorem, I can get that radical 6 squared plus the missing y squared must be equal to the 3 squared. That's 6 plus y squared equals 9. Y squared is equal to 3. So y is equal to plus or minus the square root of 3. And because y is equal to plus or minus the square root of 3, we know it's going to be the negative one specifically because we're in the fourth quadrant. And so the sine of the angle in question is going to be negative radical 3 over 3, opposite over hypotenuse. All right, continuing on, we can, of course, do some verification of trig identities, just as we did in the last video. This is going to proceed the same way. Now, you can start again on the left or the right. As a general rule, I like starting on the side that is more complicated looking. So I'm going to start with cosine to the fourth of x minus sine to the fourth of x. And, you might start to ask yourself, what can you do? Well, we already have things in terms of sines and cosines. We got some fourth powers. We don't want any in the end. But the thing that's really jumping out at me here is that this is a difference of squares. And I'm going to use that a squared minus b squared factorization form. This is the same thing as cosine squared of x minus the sine squared of x times the cosine squared of x plus the sine squared of x. Well, that's really interesting for a couple reasons. One is that this is just the Pythagorean identity that cosine squared plus sine squared is equal to 1. Cosine squared minus sine squared of x is one of our 3 identities for cosine of 2x. So this is cosine of 2x times 1, which is, of course, just cosine of 2x, which is what we were looking for in this problem, and so we have verified it. Let's go ahead and try one more problem. And this last problem, again, I'll start on the left because it's a little bit more complicated looking. So I'll start with the sine of x over the cosecant of x minus the cosine of x over secant of x. Because I've got some sines and cosines, it seems like it might be useful to me to just jump right into rewriting these all in terms of sines or cosines. So this is sine of x over 1 over sine of x minus cosine of x over 1 over cosine of x using those reciprocal identities. Find those useful because now it's all sines and cosines. Well, dividing by the fraction is the same as multiplying by the reciprocal. This is sine of x times sine of x over 1 minus cosine of x times cosine of x over 1. And so I get sine squared of x minus cosine squared of x. Now I see that sine squared minus cosine squared, and I'm thinking, hey, that looks a heck of a lot like the double angle identity for cosine. But be careful, it's not quite. This is cosine squared minus sine squared, and this is sine squared minus cosine squared. So what I'm going to do is I'm going to factor out a negative, making this negative sine squared of x plus cosine squared of x. And now that stuff in the parentheses is the negative cosine of 2x, which is what we've wanted, and we have therefore verified it. All right, once you feel you're ready, you can move on to the next video where we will talk a little bit more about some additional trig identities.